Lesson 3.4 Transformations of Cubic and Quadratic Functions. Sketching the graph can be easy. When you think about it, it's just a transformation of standard family graphs. Equations in the graph can be modified to fit the following equation, as shown in the middle of the slide, where D is the horizontal shift left and right on the x-axis. C is the vertical shift up and down on the y-axis. A is the vertical stretch or compress, and K is the horizontal stretch or compress. Let's take a look at example 1 from your learning resources. Ask us to describe the transformation that must be applied to y equals to x cubed to the graph y equals to 4 times in bracket 2x minus 8 cubed plus 5. Step 1, we have to factor the coefficient, which is k out. Remember, k is the horizontal compression or stretch. So once again, we have to start out by writing our original equation, and then we factor the k out. In this case, it will be 2. Keeping in mind that sometimes when you factor the k out, the horizontal shift, which in this case is 4, may no longer be an integer, but rather a fraction. And then we have to determine the transformation. That's step 2. We see that it has vertically stretched by a factor of 4, that's the 4 in front. It has a horizontal compression by a factor of 2, that's this 2, that's k. It translated 4 to the right because it's negative 4, and translated 5 units up, that's positive 5. Taking a look at example 2, it gives us a graph and asks us what is the family equation. Describe the transformation and what is the new equation after the transformation. Just by looking at it, we can see that the family graph is y equals to x cubed, and that's drawn out in the dotted pink line right here. We can see that our equation, which is this purple line, is stretched by a factor of 2. It's 2 times bigger than the original equation. But in the actual transformed equation, we don't write 2, rather we write 1 over 2. So the new equation will be y equals to 1 over 2 x cubed. Here we have the same equation with a different with a different graph. Just by looking at it, we can see that the original equation is y equals to x squared. It shifted upward by a factor of 3, and that's all it did. It did not shift left and right, nor did it stretch or compress. Therefore, we can conclude that the final equation is y equals to x squared plus 3. Here we have 2 more functions, in which the first one we can clearly see is y equals to x squared, but it was reflected upon the x-axis. Therefore, the final equation is f of x equals to negative x squared. The graph on the right side, we can clearly see it is y equals x cubed, but it was reflected upon the y-axis this time. So the final equation will be y equals to, in bracket, negative x cubed. Here we're given the equation, we're asked to determine the equation from the graph, and we're asked to write it in the form a times k times in bracket x minus d in bracket cubed plus c. First of all, we see that the graph has transformed 5 units to the right, 4 units down, and that's all that it did. It did not stretch or compress. So the final answer will be g of x equals to x minus 5 in bracket cubed minus 4. Here we're given a similar question. We can see that the graph reflected among the x-axis. It shifted left 8 units, 5 units up. And so the final answer is g of x equals to negative, you can actually ignore the 1 that's in front, times x minus 8 squared plus 5. This is the end of this lecture. Please do the activity as well as your assignment and upload them for your teachers to mark, and I'll see you guys next lecture.